Alright, so here's a word problem. It has a system of equations in it. So you got a couple options here. Either try to do this yourself and then pause the video, try to do it yourself, and then check your answer whenever I go through it, or you can go through it with me, but don't just sit there idly. Actually do this on your paper too, in your notes. Okay, so at a pizza restaurant, it costs $4 to make a pizza that sells for $12, right? So, it costs them maybe $4 in materials and then to pay someone to make it, but they're going to turn around and sell it for $12 so they can make some money. And it costs $6 to make a large pizza that they're going to turn around and sell for $15. In 1 week, the restaurant spent a total of $1,100 making pizzas and then sold them all for $2,910. The question is, how many small pizzas were sold? Okay, so this is a typical kind of question that you would be confronted in a math textbook that uses systems of equations. And it's kind of corny because if someone wanted to know how many small pizzas were sold, they would have just counted them up as they went, right? Who's going to use a system of equations to solve this? But this is how a math book usually works, and you just kind of get used to it. Okay, so we need to define our variables here. We need small pizzas, and the number of small pizzas, so let's call that x. So this is the number of smalls. And then we've got the number of larges, let's call that y. So large equals or y equals the number of larges. Okay, so I'm just going to make some cost equations. The first one deals with the fact that it costs $4 to make a small. So that's 4, I'm going to write up here, 4x, and then it costs $6 to make a large. So plus 6 times y. And however many x's and y's I have, I total all that up. How much should they spend making those pizzas? They spent $1,100. So plus 1,100. Okay. And then I need to make one how much money they actually made. And that is the fact that they sell the small ones for 12. So that's 12x. And then they sell the large ones for 15. That's plus 15y. And how much did they make all doing that? That is $2,910. So I'm going to probably use elimination on this. Now, you could notice that some of them are multiples. Like, for example, everything is even in the top equation, so you might divide by 2 to make your number smaller. That's one thing you could do. But let's just go ahead and maybe multiply this top equation by 3. Not just 3, but negative 3. Let's times it by negative 3 so that the x's have the opposite coefficients. So now I'm going to write down below here, down below the paragraph, I'd have a negative 12x, negative 3 times 6, so minus 18y's is equal to negative 3,300. The second equation, it doesn't change. 12x plus 15y is equal to $2,910. Okay, so let's add these suckers up. Those cancel, and I get a negative 3y is equal to, let's pull my calculator up here, turn it on. Hey, look, there's a graph. Quit out of this, and I have 2,910 minus 3,300, and I get a negative 390. Let's go back here, negative 390. I'm going to divide by 3. It's going to be positive. That goes in there 130 times, right? Okay. So that is how many larges they cooked. But we want smalls. So to get smalls, we need to stick that back in to one of the equations. How about the top one, because it's smaller there? 4x plus 6 times y, which is 130, is equal to 1,100. So multiply here, that's 600 plus 180, that's 780, 1,100. And then subtract that over, so let's subtract 780 from this. Here I get 4x is equal to 0, 10, 2, 10 is 320. So dividing by 4, I get x is equal to 80 pizzas, 80 small pizzas. What a silly question that is. I could have just counted to the number 80 whenever I was cooking them. Could have kept track of them. Anyway, math. Okay, so here is an actual SAT question from a released SAT test. And it is a system of equations, yes, but it has some squares in there and stuff. And you might have to do something strange in order to solve it. So I would encourage you to pause and see if you can try to suss this out yourself before you see my solution. Okay, so go ahead and pause. Okay. Alright, were you successful? Did you get an answer? Let's see if it matches this one. So I want to find, I'm not just solving a system of equations, I want to find what is a plus b, which is strange. It's a strange thing to find. We usually just want to find like a or b. So let me just list these equations out, and you see what might be done to get a plus b. So 8a minus b squared is equal to 24. And the second one, 8b plus b squared is equal to 56. Okay, notice that the b squareds there, they're opposites. Like if I were to add those two things together, they would cancel out. And on the left side, look, I would have a's and b's together. I would have a's and b's together. So let's just look at that. Let's just add these two equations. I would add these up. Now they don't actually combine. I just get 8a plus 8b. But the b squareds cancel. Then I add up the right hand side. That is 80. And then in order to get a plus b, which is what I'm looking for, I'll divide both sides of this by 8. When I do, I get a plus b is equal to 10. Right there. And that's kind of a strange kind of question, but that's typical of SAT, that they wouldn't ask something straightforward. Some people immediately can see what they're supposed to do. Others, you need to have the exposure to it to see what the tricks involved are before you know what to do on the SAT yourself. So there you go. Okay, one more that's kind of like SAT questions, another strange one. Again, I would suggest that you pause it to see if you can try to do it yourself first. Solve the system below by letting 1 over x equal to big X and 1 over y equal to big Y. Alright, so we're just kind of doing a substitution here to make this system easier to solve. So notice that this equation is the same thing as 12 times 1 over x minus 12 times 1 over y is equal to 7. And if I do this substitution on it, it becomes 12 big X plus, or no, not 12 big X, okay, there we go, minus 12 big Y equals 7. Okay, now I'm going to do something similar on this bottom equation here. So this is the same thing as 3 times 1 over x plus 4 times 1 over y is equal to 0. Doing the substitution that it suggested that I do, I get 3 big X plus 4 big Y is equal to 0. And now let's solve this system of equations for either x or for y. How about we solve it for, hey, these things are opposites, the y's are opposites. Let's just multiply this bottom equation times 3, right? So let's come right over here on the far left hand side. Top equation stays the same, 12 large x minus 12 large y equals 7. And on the bottom I would have 9x's plus 12y is still equal to 0. Add them up, and I would get 27. Oops. Here we go. No, 21 large x's is equal to 7. There we go. There we go. And divide it, I would get large x is equal to 7. Okay, but I don't actually want large x. I want 1 over x. So let's back substitute and make this 1 over x is equal to 7. Whoops, whoops, whoops. Silly, silly Mr. Noel. I divide by the 21. Going back to that step, I divide by 21. You get 7 over 21, which is 1/3. Okay, now I have back substitute 1 over x is equal to 1/3. And if I flip both sides of this, I get x is equal to 3. Okay, now if I wanted to do the same thing for y, let's just substitute that. Let's see, that 3 in for one of these equations. Why don't I stick it in for this one, and I can solve that thing for y, not having to worry about the weird substitution here. So I'd have 3 over 3 plus 4 over y is equal to 0. That's just 1 subtracted over. 4 over y is equal to -1. Make that over 1 cross multiply there, and you get y is equal to -4. And so there is your solution to that system of equations, 3, -4. Okay, so that concludes a little amount of challenging, crazy bit of exercising. And what we did in this lesson, it's raining out here, it's raining. We used the graphing calculator to solve a system of equations. We used the calculate menu to find the exact point of intersection. And the second one, of course, we used either substitution or elimination to solve that system. So I'm wondering if anybody out there recognizes what the illusion is with that picture there. So if you do, respond in the comments. I'm interested to see if anybody understands why I put that particular picture there. Okay, anyway, here is your assignment. Just like I asked on the previous section, I would suggest that you print out this worksheet just simply because you would have the grids on there. It's already graphed for you. It'll make it a little bit easier for you to do what you're supposed to do. Okay.